In this video, we will be solving problems with triangles in the same plane. First, let's deal with the angle of depression. The angle of depression of an object below the horizontal is the angle between the horizontal and the line of sight from an observer to a point below eye level. An observer atop a building spots a drone delivering a package to a doorway on the ground floor of a building down the street at an angle of depression of theta degrees. The observer and the drone are in the same plane. Here's the horizontal, or the observer's eye level. The observer has to depress or lower the eye level to see the drone. This is the line of sight. The angle between the horizontal and the line of sight is theta, and theta is the angle of depression. And theta is always an acute angle. Simultaneously, a camera on the drone spots the observer atop the building from the ground floor of the building down the street at an angle of elevation of beta degrees. Here's the horizontal for the drone. The drone's camera has to be raised to see the observer. This is the line of sight, and notice that the lines of sight are the same. Beta is the angle of elevation. From properties of angles, theta equals beta, meaning that the angle of elevation equals the angle of depression. The angle of depression is an important concept for some upcoming problems. Here's example 1. From the top of an 18-meter high building, a surveyor measured the angle of elevation to the top of an adjacent building and the angle of depression to the base of that same building. The surveyor sketched this plan of their measurements. Determine the height of the taller building to the nearest tenth of a meter. First, let's draw and label a diagram. Here's our diagram with our two triangles, and we have our vertices labeled A, B, C, D, and E. The known length of the smaller building is CD, which is 18 meters. The height of the larger building is given by BD. The length of BD can't be found in one step because it is not the side of a right triangle. In other words, triangle ABD is not a right triangle. But BD equals BC plus CD. Since we know CD equals 18 meters, we need to find BC. We will isolate triangle ACD and find the length of the shared side AC. This will help us find side BC. Here's triangle ACD isolated, and we have the opposite. We need the adjacent, so we're going to use tan. Tan 18 degrees is the opposite, which is CD, divided by the adjacent, which is AC. We solve tan 18 degrees equals 18 over AC, since we know CD equals 18. We write as tan 18 over 1 equals 18 over AC, and we cross multiply. 1 times 18 equals AC times tan 18. We have AC tan 18 equals 18. Isolating for AC, we divide both sides by tan 18 degrees, and we cancel tan 18 degrees to give us AC equals 18 over tan 18 degrees. Using our calculator, 18 over tan 18 degrees is 55.398,30367 continuing. So AC equals 55.3983 meters. We will keep it to 4 decimal places since we will need to round more in the future. Now we have side AC put in as 55.3983 meters. We have the adjacent, we need the opposite. So we're going to use tan again. Tan 38 degrees is the opposite BC divided by the adjacent AC. Since we know AC to be 55.3983, we solve tan 38 degrees equals BC over 55.3983. Writing the tan 38 degrees over 1, we cross multiply. 1 times BC equals 55.3983 times tan 38 degrees. We have BC equals 55.3983 times tan 38 degrees. We turn to our calculator. This gives us 43.281,89839 continuing. So BC equals 43.28189 meters. Recall that BD equals BC plus CD. So BD equals 43.28189 plus 18. We get 61.28189. So rounding to the nearest tenth, the taller building is around 61.3 meters high. Here's some practice. Army Cadet Lindell measured the angle of elevation to the top of a monument from Cadet Neary as 61 degrees. The height of the monument is 35.5 meters. Knowing that Cadet Neary is 48 meters closer than Cadet Prakash to the base of the monument, determine the angle of depression from the monument to Cadet Prakash to the nearest tenth of a degree. You may wish to hit pause here and try this on your own. First, let's draw and label a diagram. Recall that the angle of elevation equals the angle of depression, so really we just need angle P. Angle P can't be found in one step because it is not an angle of a right triangle. In other words, triangle PLN is not a right triangle. However, triangle PLM is a right triangle. We need to determine the length PM. This will help us get angle P. But PM equals PN plus NM. Since we know PN equals 48.0 meters, we need to find NM. We will isolate triangle LMN and find the length of the needed side NM. Here is triangle LMN isolated. Since we have the opposite and we need the adjacent, we use the tangent ratio. Tan 61 degrees is the opposite ML divided by the adjacent NM. Since we know ML to be 35.5, we have tan 61 degrees equals 35.5 divided by NM. Writing the tan 61 degrees over 1 and cross multiplying, we have 1 times 35.5 equals NM times tan 61 degrees. We have NM tan 61 degrees equals 35.5. Isolating for NM and dividing both sides by tan 61 degrees and canceling the tan 61s, we have NM equals 35.5 divided by tan 61 degrees. Using our calculator, 35.5 divided by tan 61 degrees is 19.677971333 continuing. NM is 19.67797 meters. Recall that PM equals PN plus NM. PM equals 48.0 plus 19.67797. So PM is 67.67797 meters. For our isolated triangle, we have the opposite and the adjacent, meaning tan P is the opposite, which is ML, divided by the adjacent PM. Tan P equals 35.5 divided by 67.67797. To find angle P, we do the inverse tan of 35.5 divided by 67.67797. We get 27.34597.025. Rounding to the nearest tenth, we get angle P is approximately 27.3 degrees. Knowing the horizontal from the monument and lowering our line of sight, our angle of depression is also 27.3 degrees. Meaning the angle of depression from the monument to Cadet Prakash is 27.3 degrees. Please proceed to the next video in this lesson, and thank you for viewing.